Something I was looking at that's not on this test review that will be on your test is to graph the logarithm, but we're gonna graph exponentials, and when you graph the logarithm, you just reverse the points to get the points for the logarithm, okay, to graph those. So let's start with the first problems on the test. Number one, it says to graph these. Now, it's gonna be really important that you pay attention to the instructions on the test, because the tests say do not guess or do not use guess and check method. You must use all the operations of logarithms when you're solving these. Don't just try to put in values for x to estimate if we get to the point. So the first one that we're going to graph is f of x is equal to 2 times 1.2 to the x. So the easiest way I think to graph these is to make your x-y chart. You pick -2, -1, 0, 1, and 2, and substitute those into the equation. Okay, so just using your calculator. Solving for what the output would be there. And graphing those points. So for -2, about 1.389. For -1, 1.667. For 0, 2. For 1, 2.4. And for 2, 2.88. Okay, so the points that we're graphing here is -2, 1.3. Okay, I still see people having trouble graphing points. What that means is we go over -2 and up a little more than 1. Over -1, up about 1, a little more than 1.5. Over 0, up 2. Over 1, up about 1, less than 2.5. Over 2, up to almost 3. Okay, so it gives you some points to work with. You have to know the overall shape of that graph. Okay, so you can see that it's increasing. So we know that it's going to get closer and closer to this x-axis and continue up. Okay. Any questions? All right. The next one says to graph -0.4 e to the x. So this is just practice using that E button on your calculator. But other than that, it's exactly what we just did. So we're going to pick our x values, -2, -1, 0, 1, 2. Use the calculator to get the y value. Give you a second to try to put some of those into your calculator. Get the outputs, making sure you know how to use that button. Anybody need help with their calculator? Huh? There it is. Huh? Put negative 0.4 times E. Minute. So negative 0.054 is what I got. Negative 0.147, negative 0.4, negative 1.087, negative 2.956. Yes.
My 0.4 is 0, I got 2 bits.
That's the same decimal equivalent, so do, shift. Anybody else?
Do that, I did, and it didn't. That's 2 bits.
Over negative 2, down a very teeny tiny bit. Over negative 1, down a teeny tiny bit more. Over 0, going down too much, down a fourth. I'll take this back up. Over 1, down a little bit past 1. Over 2, down almost 3. So this one is still using that x-axis as an asymptote. And then it's coming down this way. Okay, so it's below the x-axis because of this negative right here. Okay, any questions? Okay, all right. All right, next question, next page. All right, suppose an investment account grows according to the formula f of t is equal to 300 times 1.0125 to the 8t. So A, what is the amount of money in the account at the beginning? Okay. This is an answer for this type of problem, not the Gumpert's curve where we have a power to a power, but this is where we can just look at a number in there. But if you forget that, whenever you want the initial value of something, you're just letting time be 0. Okay, so it's equal to 300 times 1.0125 to the 8 times 0. Okay, anything to the 0 power is 1. So that's just going to be 300 times 1 or 300. When it's just an exponent that's multiplication or just an exponent that's a variable and its initial value, the initial value will always be that number that is in front. Okay, that is one that you could answer for me without showing work if you knew that. But if you don't remember that, just to always remember that initial value is when t is equal to 0 or beginning or starting. Any of those words are the same as initial. What is the value after it's open 6 months? So what I need to be careful with is to look and see how is t measured. Is t measured in years, months, weeks? How's it measured? It's in months. So if they're asking for 6 months, my time is 6. So now I'm looking for t equals to 6. I would like you to show me what you do so that I can give you partial credit if you put something wrong into the calculator. Okay, t is 6. Again. Well, there's a 1.0125. So that's what I'm talking about, right? If you had it written on your paper, I could give you a lot of partial credit. It's just a calculator problem. Yeah, 544.61. Okay, all right, so we should, because this is a word problem, we should answer this. This is an investment account. So what are the units on this? Dollars. So both of these, let's get really good at that, because I know that is something I need to check on the final exam, that you're labeling your answers when we have word problems, okay? Okay, now it says, what amount of money is in the account after 2 years? Time is measured in months, so we need to put 24 in for T. Okay, so this would be in C, 300 times 1.0125 to the 8 times 24 power. $3,258.12. Any questions on that? Y'all good with that? One just like this on the test. Okay, then the last question. All right, it says to the nearest month, how long will it take the initial amount of money to double in value? So now we're looking for T. We want to solve for T. Okay, and what is our future value that we're looking for? 600, because we want it to double. Okay, so we started with 300, so at the end, we know how long it's going to take to get to 600. All right. Divide both sides by 300. 2 is equal to 1.0125 to the 8t. Okay, what do we need to do now in order to get that exponent, that variable, down from the exponent? The log. What base would you like to use? Yeah, that messy little decimal there. All right. So, but it doesn't matter because we're just using the calculator. Log base 1.0125 of 2. And some of you like to use the ln, some of you like to use log base 10. That is absolutely fine. Log base 1.0125 of 1.0125 to the 8t power. We can bring that 8t down in front now that we have a log in front there. Log of 1.0125 to 1.0125 is 1. So we're just left with 8t is equal to log base 1.0125 of 2. Divide both sides by 8. Use the fraction button on your calculator when you put this in there. Don't try to use the division sign. Don't try to do the numerator and then hit equals and then it does answer divide and divides by 16 instead of 8. Put it all in at once using the fraction button in your calculator to get the right answer that is 7.
So
7 what?
months. So I have to show my work.
You have to show your work.
Well, what if I just took the B and saw that it was 544?
And plugged in 7. That's called guess and check. That's what you will not get credit for. Okay, and so you have to show the log. I want to test your knowledge of logarithms. I don't want to test how good you are. It's just picking a number for x. Does that make sense? Okay. Anybody else questions?
In the calculator would be solve the logs of 2 and then divide by 8.
Yes, you can do that. Just don't let it say A and S.
Okay.
Because when Dallas did that the other day, it divided by a double, right?
Nice.
It should work. I don't know why these calculators do that weird thing. All right. I wondered how you got it so fast, Chloe.
Me too. She's so simple.
Yeah, and that is what I saw a lot last semester was people just trying to guess and check, and it is really easy to guess and check, and that is, you know, a good skill to have. It's just not the skill I'm testing on here. Great skill if it's like a SAT or multiple choice test, you go for it, but not when I'm testing you on longer. All right, so we want to look at the graphs of e to the x, and in your notes you had a picture in your note packet of how each of these negatives affected the graphs. Okay, so just overall. All right, so we know that e to the x is an exponential growth function because our base is a positive number greater than 1 and x is whatever x is. So we know just from graphing exponential growth functions that they look something like that. Okay. Making your number out here negative makes it less than 1. Okay, and you can take the time to put values in here. But when a negative, I want you to think about this graph. That's a negative out in front. So it's changing whatever answer I got for e to the x. Do you agree? It's just multiplying the answer times a -1. So instead of these answers being positive, what kind of answers are these going to be? Negative. So if my y values went from positive to negative, it's just a flip over the x-axis. Okay. So this one, if you think about this graph, now I'm making all my inputs negative. The other way you could think about that would be to say that this would now be a negative exponent. It says this base is in the wrong place. So it's like 1 over e to the x, which makes that a fraction less than 1, okay, which makes it a decreasing function. Well, I want you to think about another way too. If my original graph looked like this, and now all my x values are changing, the negative ones are going to be positive x values, the positive x values are going to be negative, it gives me a decreasing function. This is this graph with just the opposite y values. So these values are all going to flip again over the x-axis. Like that. Any questions? Number 4, solve the following equations. Give your answers in exact form or round to 3 decimal places. All right, so log base 2 of x is equal to 8. When I look at this, my variable is not my exponent, right? So I don't even have an exponent, so I'd like to get rid of the log. How do we get rid of a log base 2? What? You can, yes, you can change it to exponential form. So there's actually 2 ways to think about this. So we could do 2 to the 8 equals x. And solve it. The other thing you can do. Anybody know another way to solve that? How do we get rid of log base 2? Give both sides a base that matches this base. So I could say 2 to the log base 2 of x power, 2 to the 8. These both become exponents. Then we know that 2 log base 2 is 1, so that just becomes x equals 2 to the 8. Gets us exactly to the same place. Okay. And so x is equal to what? 256, good. Bless you. All right, log base 4 of 3x minus 5 is equal to 1. Use your big circle or take a base of 4 to both sides to solve that. We just have a basic algebra problem now to solve. We want to get the x by itself. So we're going to add 5 to both sides. 3x equals 9. Divide by 3. X equals 3. Any questions on that? It's like to the 1 power, then you have to 4 to the first power is 4. Anything to the first power is that number itself. Okay, C, the next one. 3 ln of 2x plus 1 minus 2 is equal to 6. So there's a couple of different ways that I could do this problem. Okay, but the first step should be the same for everybody. What should we do first there? Add the 2 to both sides. So we want to isolate that ln so that we just have a log with something there. So we want to add 2 to both sides. So we get 3 ln 2x plus 1 equals plus 2 plus 2, 8. Okay. What next should we do? Divide both sides by 3. I think it's going to be the easiest thing. The other thing that you could do would be to take that 3 up, but to cube this would actually be somewhat difficult to do. So I would suggest dividing by the 3 first. So we have ln of 2x plus 1 is equal to 8/3. Okay, now we're ready for that ln to disappear. How can we make it disappear? Yeah, take a base of e to both sides. Good job. Because ln is log base e, so this is 1. So 2x plus 1 is equal to e, use your fraction button, to the 8/3. Is the 8/3 an exponent? It is an exponent, yes. Because when we put a base of e, we make both of these things an exponent. Every time we're doing them. Just like the 1 became an exponent for that 4.
Wait, what do we put? We just put e to the 8/3 in the calculator?
Short. Okay, and I kept it as 8/3 until I finished doing this. So the next thing that we would do after we get that decimal, if you changed it to a decimal, would be to do what? Subtract the 1. So plus you 2x minus 1 is equal to e to the 8/3 minus 1. And then to get the x by itself, we divide by 2. So mine came out to be 6.696, somewhere in there. Okay, you might be slightly different than me if you changed this to a decimal and then subtracted 1 and divided by 2. Kip, you good? What's wrong?
Yeah, I changed it to decimal.
Okay. Did you get the same final answer though?
No, I got 26.
Oh, there is something wrong.
Oh, no.
Anybody else? Yeah, even if you change it to a decimal, it should be fairly close to that. All right. C. 3 times 4 to the x is equal to 17. We want to isolate the exponential in this. That means we want just a base with some kind of exponent by itself. So we need to get rid of everything else. How do we get rid of the 3? Divide, because it is multiplied. So we have 4 to the x is equal to 17/3. I need to get the variable out of the exponent, and the only way we know how to do that is to do what? Take the log. What base log should we use? Good. Log base 4 of 4 to the x is equal to log base 4 of 17/3. Doing this with the pressure of the test, a lot of times students forget to take the log, okay? Somehow they just bring the exponents down. Remember, you got to do the log, you got to take the log of both sides. All right, log base 4 of 4 is 1, and we can change that to multiplication to the power of powerful. X is equal to log base 4 of 17/3. You 5 points? Okay. Question? You're good? Okay. Yeah. Let's see. It was math. There's. Anything else? Questions? Well. Seven to the 0.5 x equals 64. Good. What do we do first? Divide by 12. How many simplifies? What? Huh? 5.3. Is it a 5.3 repeating? Gonna do 4 decimal places because it really does make a difference with your answer. All right, and now we need to do what to both sides? Log base 7. Log base 7 is 7. Yeah.
Use some places before we go, they keep it in the front.
Yeah, that's how I would have done it. I just was using what y'all gave me. Yep. Log base 7 of 7 is 1, and we can change this to multiplication. 0.5x is equal to log base 7 of 5.3333. And then we want the x by itself. The 0.5 is multiplying by it, so we're going to divide that. Again, use your fraction button to put that into your calculator. And I got somewhere around 1.721. I did use the fraction. Yeah. Me? We can look at it. Hey. Bacteria colony doubles its population every 15 hours. The expected population after T hours is given by the function population is equal to 125 times 2 to the T divided by 15 power. What is the initial population? A, initial population is when time is 0. So substitute 0 in for time. Label your answer. What is the population in 1 day? What are we substituting for time? Go always on these, go back and look at your units. And it says that time is measured in hours, right? So in this case, for T, we're using 24. For that 378.93 bacteria. Yes? Everybody got a fraction for the exponent, huh? I don't know why I said 25, but thank you. Making my, I guess I was doing spring back or fall back. Time change. Just 25 hours. Questions on that one? Anybody?
We had to like put it as like the whole number because it's. Can't have like that.
No, you can't. If I would like to see this and then you could tell me which way you rounded. So I know you didn't guess. Okay. So how long does it take for the population to equal 1,200? So that's a future value. So we're putting that in for the answer. So this one's going to be our log problem. That's the first step there. Now, yeah, we gotta get that two to the T over 15 isolated, so we need to get rid of the 125. So we need to, it's multiplying by it, so we're gonna divide by 125. So we have 1,200 divided by 125, whatever that is equal to 2 the T over 15. Okay, now we've got it isolated. The variable is an exponent, so we're going to take log base what? 2 of both sides. You could simplify that if you wanted to, that's fine. Log base 2 of 2 is 1, and we can apply our power to a power rule, so we can bring that down in front. Log base 2 of 1,200 divided by 125 is equal to T divided by, bless you, 15. I want the T by itself. How do I get rid of the 15? Multiply, because it's being divided. So multiply both sides by 15. From there, just put it into your calculator. Is equal to about 4,894,648. And T is measured in hours. Okay, so making sure you label these word problems. Ready? Yes, no, maybe? Yeah, okay. The size in grams of a sample of radioactive substance is given by the formula Q is equal to 300 e to the negative 0.02 T, where T is measured in weeks. What is the initial size? The initial size is when T is what? Good. 300 e to the negative 0.0 T times 0. What's the answer gonna be? 300. 300 grams. Okay, then it says what's the half-life? So we're gonna look for time. If we're looking for the half-life, what's the future value of the grams of the substance? 150, half of our initial value. So 150 is equal to 300 e to the negative 0.02 T. Before we do anything, we have to isolate the exponential. The exponential is this e to the negative 0.02 T, so we need to get rid of the 300 by dividing. That will always reduce if we're talking about half-life to half. Okay, if it's doubling time, it will always reduce to 2. Is equal to e to the negative 0.02 T. What are we going to do to both sides? Natural log, because the natural log is log base e. Ln e is 1. So we left with negative 0.02 T is equal to the natural log of 1/2. We just want the T by itself, so that negative 0.02 is multiplying. So to get rid of it, we're going to divide. Just throw it in your calculator using the fraction button. Got 34.657, and that's measured in weeks. Is that about right? Is that what you got? LNE is log base E of E. So my base and my argument match, so it's just one. And then the other comes, this comes down in front to multiply. Any questions? All right. Then we have a couple of problems that it says use whatever method you want to solve this. Okay, so log base 5 of 625. Okay, it's just a statement. When it gives you just a statement, it's asking you to simplify it. For those of you who like to change it to an exponential, we can easily do that. We can just put equals x here. Okay, and then you can use the circle. 5 to the x is equal to 625. Yeah.
Put it in our calculator or change the base or whatever. It's still want us to change it into super.
Yeah. No, you can put it in your, just put it in your calculator. Yep. Okay, but, and I assume everybody's just gonna put it in their calculator. Yeah.
Yes.
Okay, all right. So what do we get for that answer? We could make the bases the same. And then find that answer that way. Okay, without calculator. All right. LNE of 2. What's the answer? 2. Good, because LNE is 1. And we can use our power to a power or drop down rule. That's 2 times 1, which is 2. Good. All right. The next one. Again, I assume y'all are just going to use your calculators for this. -2. All right. So if you were looking at it this way, it would be 3 to the x is equal to 1/9, which is 3 to the x is equal to 3 to the -2. So x is -2. And the last one, log base 9 of 3 is equal to x. You put that right into your calculator again. 9 to the x is equal to 3. What do we get? Half. Y'all feel good about this test?
Yes.
All right, the only thing that I did not do, and because these graphing of logarithms were not the same, was to do a log graph, but that we just switch the x and y values, okay, and graph it. Notice there was none of that power to a power, like the Gumpert's curve, there were none of those on this. But there's none of those on the test either, okay? That was in your homework.